Using groups can make analysis of multiple files very quick and easy, as any changes made to one sample, such as drawing gates or changing parameters, are automatically applied to every other file in the group. To create a group, highlight the files in the file inspector that you wish to group, right-click, choose Group, and Add to New, and the group will be color-coded. The group color can be changed by right-clicking, choosing Group, Set Color, and then choosing a new color from the options. It's also possible to have multiple groups in the same folder. Grouped files or individual files can also be added to existing groups. The benefit of group analysis can be seen when we start to draw gates. Here, if I open the first file and draw a polygon gate, we can see that this P1 gate is automatically applied to every sample in the group. If I right-click on this gate in the file inspector and rename it, you will see that the new name is automatically updated on all samples in the group. Likewise, if an adjustment is made to one gate in the group, for example this polygon gate, the adjustment is also updated on all other samples. Another feature in FlowLogic that gives a lot of power to group analysis is the ability to quickly select a particular level in the hierarchy on all samples. To do this, select and right-click on the desired level of the hierarchy on one sample, choose Rows, and either Highlight Level or Highlight Level within Group. And this will highlight that level on every sample. Now, if I right-click and choose Plots and Open, I can open those particular plots corresponding to that particular level of the hierarchy for every sample. Because I am working in groups, if I change the parameters on one sample, it will change the parameters for all samples in the group. Likewise, changing the plot display option for one sample in the group will update for all. Now I will add a rectangle gate to the first sample in the group, and having all of the samples open in the workspace allows a visualization of that gate on every one of those samples. Again, renaming a gate on one sample in the group will rename it for all. It is also possible to close all plots in the workspace at once by right-clicking in the file inspector, choosing Plots and Close All Plots. And now I can select this new level of the hierarchy on all samples and open the corresponding plots. I will continue this analysis by adding one more gate to this subpopulation. And as you can see, using groups to analyze is very fast and very useful, as it enables you to visualize the gates being applied to every single sample. The next thing I'd like to demonstrate is the effectiveness of backgating whilst using groups. In order to backgate a population, open the plot side drawer using the arrows in the bottom left-hand corner, and under the Gate List tab, identify the gate, choose a color, and tick On, and this will color this population for all samples in the group and at every level of the hierarchy. And, as you will see, adjusting the gate on one plot will update the gate position and the colored events on all plots. If you wish to adjust one gate only, it is possible to remove a single gate from a group. To do this, right-click on the gate or selection of gates, choose Group, and Remove, and you will see the group color has been removed from this population. Now, if I move this one gate, you will see that it doesn't update on any other populations that exist in the group. The easiest way to return this gate to the group is to copy the gates from another sample that is in the group and paste it on to this original sample. And now, all gates are back in the group. As demonstrated before, changing the parameters on one plot from a group will update the parameters on all plots, and also changing the plot display option on one plot will update for the remaining plots in the group. And at any stage, clicking on the gate name in the plot side drawer from one plot will return the parameters to the combination where the gate is drawn for all plots. The only aspect that isn't updated in the group is compensation. So here, if we open the plot side drawer and change the compensation for this one file, you will see that it doesn't update for any other plot in the group. Of course, this new compensation can be copied from this sample and pasted to all other samples in the group by right-clicking on the sample, choosing compensation and copy new, then selecting the remaining files, right-clicking, choosing compensation and paste. In addition, the original compensation matrix, created at acquisition, can be reapplied to this sample. Another advantage of working with groups is in the calculation of the statistics in the Advanced Functions pull-up drawer. So here, if we select the Set Statistics tabs, we only have to have one sample highlighted in the file inspector, and the selected statistics will be calculated for all samples. In addition, if a gate is moved on one plot, all statistics linked to that one gate will be updated for the group. In addition to being able to remove one or a selection of gates from a group, it is also possible to create additional groups of selected gates. For example, if I select these matching gates from the first two samples, right-click, choose Groups and Add to New, you will see a new group has been created, in this case coloured yellow. Now, if I move one of these two gates, only that gate in the first two samples is updated. I can continue to create additional groups, and you will see that they will be assigned a new colour. So now I have 3 different groups for this one particular gate. I can also return all of these gates to an existing group by highlighting them in the file inspector, right-clicking, choosing Group and Add to Existing, and then choosing the group by colour. If there are gates of different positions being returned to a group, then it will be the gate that is listed highest up in the file inspector list that will determine the new gate position for that group. Group analysis is also useful when it comes to deleting gates. If a gate from one sample is chosen and deleted, then this will remove that same gate from all samples in the group. Another useful feature in FlowLogic that is made even more powerful with the use of group analysis is the ability to build plates from the file navigator displaying the entire gating hierarchy. To do this, right-click on the experiment folder and choose Build Plate with Images, and this will create a plate displaying every sample in a new column, and as gates are created, a new row will be added to the plate displaying the daughter population. Double-clicking on any well in the plate will open the plot in the workspace, and as these samples are all grouped, I can add my gates to this one individual sample and in real time watch the plate grow and update. This is a very useful way to be able to view every single plot in your analysis and, for example, directly compare your test samples to your experimental or staining controls. The plate itself is a live representation of every single plot in the analysis, so repositioning a gate or even a gate label will update on all of the plots in the plate. And for example, if I perform coloured backgating on this population here, you will see that it is applied in real time to the entire plate. And the coloured events in the plate will all update as this gate is moved. Finally, this plate itself can be exported by right-clicking on the plate, or it can be added directly to a report in DocLogic.